Hi, welcome to Anil Nair classes. Thank you for watching one of the most weighted video in 2020, that is divisibility rule for a prime number. Generally, in our school days, right from 7th class, 8th class, 9th class, it is taught that divisibility rule for a prime number. For 2 it is taught, for 3 it is taught, for 5 it is taught, for 11 it is taught, but beyond that it becomes an out of syllabus in our school days. Now today, most of the concepts whatever I am going to teach is something, it is not available on YouTube till now. If you type divisibility rule for 14:7, there will be a very generic method that will come. Today, whatever the video that I am keeping is very, very special to my heart, and there has been a lot of research that has happened in referring some of the best books on mathematics, like Hungarian Book of Mathematics, Mental Max Calculation by Arthur Benjamin, Trachtenberg book, and some of the best books from the world's best educational system, that is Finland. This class, kindly watch each and every slide, make a note of every key point that I am explaining beyond the problem solving. Kindly don't watch this class from a competitive examination perspective. Watch this class to understand how a prime number divisibility rule is generated, how by using this logic you can solve some of the 5 toughest questions. Just by looking at a question, you can answer it immediately. Let us jump into it. Divisibility rules. I am not going to discuss something you already know. Divisibility rules for selected prime numbers. In my next session, I am going to make my students develop their own divisibility rule for every prime number. You can develop your own divisibility rule for every prime number once you understand today's concept. I am not going to use the theory of oscillation, which is the most popular concept which is present in every book or in every video. I am not going to use take the unit digit, double it, add it to the remaining part of the number, take the unit digit, multiplied by 7 times, add it to the remaining part to get the divisibility rule of 23. If anybody is expecting that I am going to teach this, kindly do not expect that one, right? Please do not message me for class link when the class is under progress. In case if you want a class link, kindly go to Anil Nair classes, subscribe to our YouTube channel. You can see the live button, click and watch the class. Right after the class is over, I am going to make the class private for a non-enrolled students. A part of it will be available for the non-enrolled students. Anil Nair classes work like an Hotstar business model. That means 90 minutes of entire live cricket match will be available only to the students who purchase it. A 15 minutes live telecast is being given free to every user who installs the app. Same model we follow. Now listen carefully. Listen to each and every concept. I am so excited to teach this concept to each one of you. Those of you who are new to my classes, who are listening to my classes for the first time, my name is Anil Nair. I was the youngest South India academic head for Career Launcher. I am an author of 9 mathematical books. I took session for more than 1000 students, minimum 500 times in a class. I generally take sessions in the biggest auditoriums and for the best engineering colleges only. I don't take sessions in colleges where the auditorium strength is less than 500. Each and every concept what I am explaining, kindly write it down in your notebook. At the end of the class, kindly revisit it, understand it. Maybe you will have some doubts. Feel free to send a mail to support@anilnairclasses.com. My team will be very happy to reply back within 2 days of time after you post the doubts. Watch the entire lecture. Don't leave in between, because I am a great believer of thematic based learning. I will start from basics and I will go to the advanced level. Initially, I take classes like a Rohit Sharma. I go slow, but once I get into form, it is nothing but bulldozing the ball out of the ground. Right? To watch the entire lecture, at the end of the session, you will be able to solve some of the toughest questions in probably less than a second's time once you understand the concept. Till understanding, it requires your patience time. Kindly share this video to every friend present in every WhatsApp group. Share this WhatsApp group. It is the first time I am taking the divisibility rule for a selected prime number. You will be mesmerized by the end of the class. Now, kindly, those of you who don't know, we are ranked number 1 in Google reviews all over India. Type Anil Nair classes Bangalore reviews. You will come to know what the world is talking about me. The picture which you are seeing on the screen is from one of the best engineering colleges in Karnataka with 2,800 students attend. 3,643 Google reviews with a rating of 4.8 out of 5. You have joined in some classroom coaching center. You are going for an online classes. Kindly check the number of reviews that we got with the coaching center that you are going through it. Let us straight away get into the class. Divisibility rule. First concept, concept 1, divisibility rule for 7, 11, 13. First I will discuss divisibility rule for 7, 11, 13. All the divisibility rules, whatever the divisibility rules that I am explaining are derived from Fermat's theorem. Fermat's theorem states, reminder, when a power p minus 1 when divided by p, it is 1. When a and p are co-primes, two numbers are said to be co-primes if their HCF is 1 and the denominator is a prime number. Whatever the entire concepts, whatever I am developing today, are primarily taken from Fermat's theorem as an inspiration. Reminder, when a power p minus 1 when divided by p gives 1, when a and p are co-primes, two numbers are said to be co-primes if their HCF is 1. Fermat's theorem holds good when the denominator is a prime number. First concept, divisibility rule. Everything, whatever I am explaining the concept, kindly listen carefully. Divisibility rule for 7, 11, 13. Only composite numbers we are going to discuss today. Now, according to Fermat's theorem, reminder, when 10 power a power p minus 1 when divided by p, it is 1. A power p minus 1 when divided by p, it is 1. That means if the denominator is 7, power will be 6. 10 power 6 when divided by 7, it is 1. When 10 power 6 divided by 7 is 1, can I write it as 10 cube whole square when divided by 7, it is 1. 10 cube divided by 7, if I call it as x square is 1. That means x will become plus or minus 1. I will check it out for 10 cube divided by 7. It should give you either 1 or minus 1, because 1 square is 1 and minus 1 square is 1. 7 ones are 7. 3 cube 27. 7 fours are 28. It is minus 1. So 10 cube by 7, I got it as minus 1. 10 cube by 11. 10 cube by 11. 11 ones are 11. Minus 1. Minus 1 whole cube is minus 1. 10 cube divided by 13. 13 ones are 13. Minus 3. Minus 3 cube is minus 27. 13 minus 2s are minus 26. It is minus 1. That means if you observe, 10 power 3 divided by 7 is minus 1. 10 power 3 divided by 11 is minus 1. 10 power 3 divided by 13 is minus 1. This is a very, very important observation, because theory of oscillation is an efficient method. If the number of digits are 1, 2, 3, 4, 5, 6, as the number of digits grows, using theory of oscillation might be a very ineffective method. That means, reminder 1, 10 cube divided by 7 is minus 1. 10 cube divided by 11 is minus 1. 10 cube divided by 13 is also minus 1. 13 is also minus 1. How it is useful? One example. Once you understand the basics, all the prime numbers becomes very easy. 1, 2, 3, 4, 5, 6 divided by 7. Can I write like this? Remainder of 1, 2, 3 into 10 cube plus 456 divided by 7. 10 cube divided by 7 is minus 1. Minus 1 into 123 is minus 123. 456 minus 123 is 333 divided by 7. 7 4s are 28. 53. 7 7s are 49. What is the remainder? 4. I hope this basic idea it is clear, because once you are familiar with the lowest prime numbers, it could be 7, 11, 13, right? Then the larger prime numbers becomes very, very easy for you. That means if you observe one more example, remainder 1, 112, 112 divided by 13. This is nothing but 112 into 10 cube plus 112 divided by 13. 10 cube by 13 is minus 1. Minus 112 plus 112. It is 0. It is 0. For this example, remainder 112 divided by 13, which is 112 into 10 cube plus 112 divided by 13. I hope this example is very clear. When I am taking a class, kindly write it when you are listening to it. In case if you are watching it in the mobile, you should have a notebook and a pen and write it in the same way. You should co-travel with me in every problem, in every slide, whatever I am explaining you. Then only it will be an extremely mesmerizing technique for you. Otherwise, it will be like just another class listened. I do not want my students just to take screenshot and kill the beauty of this concept. Please co-travel with me. I hope it is clear. Now, some important conclusions. Divisibility rule for 7, 11, 13. There are three important key points. Concept 1. Start from right hand side. Take a group of 3 digits. Alternatively add and subtract. If you do alternatively add and subtract from a group of 3 digits, you get the divisibility rule for 7, 11, 13. Not only for 7, 11, 13. 77 divisibility rule is 7 into 11. 91 divisibility rule is 7 into 13. 143 divisibility rule is 11 into 13. 1001 divisibility rule is 7 into 11 into 13. Because composite number divisibility rule is nothing but write the number as a product of coprimes. Start from right hand side, take a group of 3 digits, alternatively add and subtract. This is the divisibility rule for 7, 11, 13. I hope it is clear. Concept 2. any three digit number written even number of times, any three digit number written even number of times is always divisible by 7, 11, 13 and its combination. If you write any three digit number even number of times, it will always be divisible by 7, 11, 13. With example, suppose if I write 243, 243, 243, 243 divided by 13. What is the divisibility rule for 7, 11, 13? Start from right hand side. Start from right hand side. Take a group of three digits. Alternatively add and subtract. Alternatively add and subtract. 243 minus 243 is 0. Again, 243 minus 243 is 0. So, two important things. First is the generic divisibility rule for 7. Start from right hand side. Take a group of three digits. Alternatively add and subtract. Any three digit number written even number of times is always divisible by 7, 11 and 13. I hope this concept is clear. Third concept. Any non-zero single digit written in groups of 6 is always divisible by 7, 11, 13. Is always divisible by 7, 11, 13. Why a single digit, non-zero single digit written in groups of 6 will always be divisible by 7, 11, 13. Why? Because, reminder, 2, 2, 2. If 2 is written 6 times, a group of 3 digits, put a slash, alternatively add and subtract. 222 minus 222 is 0. Are you all with me? Right? Suppose if it is 7, 7, 7, 7, 7 written 85 times divided by 13. 7, 7, 7 written 85 times when divided by 13. This is nothing but, if 7 is written 6 times, any non-zero single digit written in groups of 6, it is divisible by 7, 11, 13. So it is 0. 6 times it is 0. Not only 6 times, but any multiple of 6 times it is 0. 12 times it is 0. And so on up to, what is the multiple of 6 till 85? 6. 14s are 84 times it is 0. What is the remaining? 1, 7. 1, 7 is left. 1, 7 is left. I hope divisibility rule for 7, 11, 13. I hope it is clear. Are you all with me? I hope this idea is clear. 7, 11, 13 is the basic foundation. Slowly I will scale it up. 3 important concepts. Start from right hand side. Take a group of 3 digits. Alternatively add and subtract. That is the divisibility rule for 7, 11, 13. Any 3 digit number written even number of times, it is also divisible by 7, 11, 13. That is for a 3 digit number. What if it is a non-zero singular digit? If it is a non-zero singular digit written in groups of 6, is always divisible by 7, 11, 13. 3 concepts clear? 7, 11, 13. You should be able to solve a lot of questions. Suppose one more question. Remainder of 5, 5, 5, 5, 5, 37 times divided by 7. Tell me the answer. 5, 5, 5 written 37 times divided by 7. If 5 is written 6 times, answer is 0. What is the multiple of 6 till 37? 6 6 are 36. How many 5s are remaining? 1 5 is remaining. 1 5 is remaining. Are you all with me? 7, 11, 13. I think it should be clear. Next, divisibility rule. Only prime number divisibility rules I am going to discuss. Next one. Now see here. Next concept. Find the divisibility rule for 37, 27. Even though 27 is a composite number, I am taking it together. I am taking it with a reason. The reason is 37 into 27 is 999. 37 into 27 is 999. That means if I take 999 is closer to which power of 10? It is closer to 1000. 10 cube divided by 1000. 10 cube divided by 37. 1000 can be written as 999 plus 1 when divided by 37. 999 is divisible by 37. What is the remainder? Remainder is 1. 10 cube divided by 37 is 1. The way your mind is thinking, it is right. If it is minus 1, we have started from a group of 3 digits, alternatively add and subtract. If it is 1, just keep on adding. Similarly, remainder 1, 10 cube divided by 27, which is nothing but 1000 is 999 plus 1 divided by 27. This is divisible. Answer is 1. That means, what is the divisibility rule for 37 and 27? Start from right hand side. Take a group of 3 digits. Because it is 1, add them. Take a group of 3 digits, add them. 37 into 27 is 999. Look out for that numbers. Which are 1 less than 10 power k or 1 more than 10 power k. We are finding the numbers which on product will give 10 power k plus or minus 1. We are trying to find out the numbers which will give product as 10 power k plus or minus 1. Start from right hand side, take a group of 3 digits and add them. I hope the concept is clear. Now we will take an example. Absolutely pay attention to the class. Please tell to the world that you are busy learning some concepts. Give me 1.5 hour time. I will make you think in such a way that you will start understanding the root cause behind the prime number divisibility rule. Example. 10 cube divided by 37 is 1. 10 cube divided by 27 is 1. This is the concept. 2-3 examples which we will do. Example 1. Remainder 1. 1, 2, 3, 4, 5, 6 divided by 37. The divisibility rule for 37 is, start from right hand side, take a group of 3 digits and add them. 10 cube divided by 37 is 1. So this is nothing but 123 plus 456 divided by 37. So answer is nothing but remainder of 123 plus 456 is 579. 579 divided by 37. 37 ones are 37. 209. 37 6 are 222. It is 13 less. So answer is 24. Answer is 24. I hope the idea is clear. Start from right hand side. Take a group of 3 digits. Keep on adding them. If you got minus 1, alternatively it will be add and subtract. If you got plus 1, it is just keep on adding depending upon the power of 10 which gave you plus 1. I hope the first example is clear. Second example, concept I am writing it here. 10 cube divided by 37 is 1. 10 power 3 divided by 27 is 1. Example 2. The question can also be asked like this. Reminder 1. 1, 2, 3, 1, 2, 3, 1, 2, 3 divided by 37. So, divisibility rule of 37 is take a group of 3 digits, add them. So, these are nothing but 123 is added 3 times. So, it is 3 into 123 divided by 37. 37 3s are 111. Remainder is 12. 12 3s are 36. 12 3s are 36. I hope the idea is clear. 123 is added 3 times. If 123 is added 2 times, it is 123 into 2. If 123 is added 3 times, it is 123 into 3. The same question can also be asked like this. 1, 2, 3, 1, 2, 3, 1, 2, 3, 300 digits. 300 digits divided by 27. 1, 2, 3, 1, 2, 3, 1, 2, 3, 300 digits. If you observe closely, 1, 2, 3, 1, 2, 3, if I write it, 1, 2, 3, 1, 2, 3, total how many digits are there? 6 digits are there. How many groups of 3 are there? 2 groups of 3 digits are there. It is 2 into 123. Am I right? Here, it is nothing but 300 digits. If I take 123 as one group, 123 as one group, another 123 as another group, every group contains how many digits? 3 digits. Like that, how many groups I got? 100 groups I got, divided by 27. Are you all with me? So, if 123 is added 2 times, it is 123 into 2. If 123 is added 100 times, it is 123 into 100 divided by 27. Are you all with me? 300 digits. 123 number has got 3 digits. That number is written in the form of 300 digits. It is as equivalent to saying 123 is written 100 times. If 123 is written 2 times, when you divide it by 37 or 27, it will become 2 into 123. If 123 is written 100 times, it will become 123 into 100. 27 4s are 108, it is 15. 27 3s are 81, it is, or 27 4s are 108, it is minus 8, divided by 27. 120, 27 4s are 108, it is 12. So, answer is 15. Concept, conclusions and example. That is how I am going to take. Concept, conclusion and example. Concept, conclusion and example. Only 2 concepts I discussed majorly. Divisibility rule for 7, 11, 13. Divisibility rule for 37, 27. These 2 I discussed. Next one. Concept 3. Major concepts. Divisibility rule for 101, 99. Divisibility rule for 101, 99. Another beautiful concept, sir. We are trying to find out for the numbers which are of the form 10 power k plus or minus 1. 101, which is nothing but 10 square divided by 101. 101 is closer to 100. So, I took 10 square. 100 divided by 101. What is the answer? Minus 1. Minus 1. Similarly, if I take 10 square divided by 99, 100 divided by 99, what is the positive remainder? 1. 10 square divided by 101 is minus 1. Whenever you got minus 1, the entire divisibility rule lies in the power of 10. What is the power? 2. So, what is the logic? Start from right hand side. We will always move from right hand side to left hand side, because right hand side unit digit is there, then tens place, then hundreds place. We write the numbers from right to left, right, then we give a value to it. 123, 3 is in units place, 2 is in tens place, 1 is in hundreds place. Start from right hand side. Take a group of 2 digits. Take a group of 2 digits. Take a group of 2 digits. Alternatively add and subtract. Alternatively add and subtract. Alternatively add and subtract. Why alternatively add and subtract? Because of this -1. What is the divisibility rule for 99? I got 1. Start from right hand side. Start from right hand side. Take a group of 2 digits. Take a group of 2 digits. Add them. Take a group of 2 digits. Add them. I hope it is clear. One example. Reminder 1. 1, 2, 3, 4 divided by 101. It is 12 into 10 square plus 34 divided by 101. 100 divided by 101 minus 1. 34 minus 12 is 22. 22. Just by looking at a question itself, you can say the answer. Similarly, 1, 2, 3, 4 divided by 99, which is nothing but 12 into 10 square plus 34 divided by 99. 100 divided by 99, 1. 34 plus 12 is 46. 34 plus 12 is 46. Very simple example we have taken. In the next slide, we will take more and more examples. Only conceptual clarity. Conceptual clarity is the key to your success. 10 square divided by 101 minus 1. 10 square divided by 99, 1. I hope this concept is clear. Depending upon the power, I will do alternatively add and subtract. If it is 1, I will do addition. Simple example I have taken. Now let me take some more example. Reminder 1. 10 square divided by 101, which is minus 1. What does that mean? If I take a 2-digit number, I wrote it 2 times. So this is nothing but remainder of 12 into 10 square plus 12 divided by 101. 100 divided by 101 minus 1. Minus 12 plus 12. What is the answer? 0. That means any 2-digit number, you take any 2-digit number written even number of times. Any 2-digit number written even number of times is always divisible by 101. You take any 2-digit number, if I write even number of times, it is always divisible by 101. Extremely important point. Whenever you are struggling in some of the counting based problems, 101, this will come into picture. Suppose if it is 36, 36, 36, 36, 36 divided by 101. Any 2-digit number written even number of times, it is always divisible by 101. I hope the idea is clear. Idea clear, right? One more example. Idea is very clear. Any 2-digit number written even number of times is always divisible by 101. Similarly, one more example. Reminder 1. 10 square divided by 99, which is 1. Suppose if I take a little bigger number. 32, 32, 32, 32, 32. 32 is written 4 times. Divided by 99. So these are nothing but take a group of 2 digits and add them. Plus, 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 plus. 32 into 4 divided by 99. 32 fours are 128. divided by 99, which is nothing but 29. I hope the idea is clear. What are the concepts we discussed? We discussed the divisibility rule for 7, 11, 13. We discussed the divisibility rule for 37 and 27. We discussed the divisibility rule for 101 and 99. Are you all with me? Right. Next one. Next one. Idea clear, right? Now, divisibility rule for 73 and 371 and 371. The best way to solve this problem is, please open your calci. If you are using mobile, please open your calculator. Find out. Right? First I will do a little smaller number, then we will go to little bigger number. Divisibility rule for, first I will do it for divisibility rule for 41 and 271. I want to start with a little smaller number, 41 and 271. Take your calculator, calculate 41 into 271. 41 into 271. What did you observe? 41 into 271. It has given you 5 ones. Are you all with me? In case if you have checked it out in the mobile, 41 into 271 has given you 5 ones. Now, because it has given you 5 ones, let me see 10 power 5 divided by 41. What is 10 power 5? 10 power 5, okay. 10 square, can I write it as 99 plus 1? Are you all with me? 10 square, I can write it as 99 plus 1. 10 cube, I can write it as 999 plus 1. 10 power 4, I can write it as 4 nines plus 1. 10 power 5, I can write it as 5 nines plus 1. Are you all with me? Divided by 41. 5 nines can be written as 9 into 5 ones plus 1 divided by 41. Are you all with me? 5 ones divided by 41. 5 ones is nothing but a multiple of 41. Are you all with me? 5 ones is nothing but a multiple of 41. So, it is nothing but, how much is the remainder we got? 0 plus 1. So, here it is nothing but 1 we got. Are you all with me? 10 power 5 is nothing but 5 nines. 5 nines is 9 into 5 ones plus 1. 5 ones is divisible by 41. Same thing also holds good for 271 also, because 271 is also a factor of 5 ones. That also has given you 1. Please make a note of it. 10 power 5 divided by 41 is 1, or 10 power 5 divided by 271 is 1. Got the idea? 10 power 5 divided by 41 is 1, or 10 power 5 divided by 271 is 1. The entire idea is based on finding what are the factors for 5 ones. 1, 1, 1, 1, 1. Because I know for that reason that 10 power 5 can be written as 5 nines plus 1 divided by 41. 5 nines can be written as 9 into 5 ones divided by 41. Are you all with me? Idea clear? Now, once you got 1 with the power of 10, now the idea is extremely easy to you. Suppose if the question is, we'll write down here, reminder when 10 power 5 divided by 41 is 1, and reminder when 10 power 5 divided by 271 is also 1. That means if the question is reminder 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 divided by 41, 10 power 5 divided by 41 is 1. Start from right hand side. Take a group of 5 digits, add them. So answer is nothing but 2 into 1, 2, 3, 4, 5 divided by 41. Are you all with me? Right? Idea clear, right? Remainder of 2 into 41 3s are 123, 45 1s are 45, 4. So 8 divided by 41 is 8. So what is the divisibility rule for 41 and 271? Start from right hand side. Take a group of 5 digits. Take a group of 5 digits and add them. Start from right hand side. Take a group of 5 digits and add them. That is the divisibility rule for 41 into 271. The root cause of this problem is 41 into 271 is 5 ones. Because 41 into 271 is 5 ones, I am able to deduce a rule. I hope it is clear, right? 41 and 271 are also over. Another concept. Divisibility rule for 73 and 137. Divisibility rule for 73 and 137. Take your mobiles in case if you are have it. Try to do 73 into 137. If you do 73 into 137, this is nothing but 10 power 4 plus 1. I got an idea? What Anil Nair is thinking in the mind, I am trying to find out the numbers which are of the form 10 power k plus or minus 1, finding out the factors and developing the divisibility rule for that factors. That is what is happening in my mind. 73 into 137 is 1 followed by triple zeros ending with 1. That means 10 power 4 divided by 73. This can be written as 10 power 4 plus 1 minus 1 divided by 73. 10 power 4 plus 1 is nothing but this number. So what is remaining? Remaining is minus 1. Are you all with me? 10 power 4 divided by 73 is minus 1. Sir, I want a generic reminder proof. That also you can do. 10 square whole square divided by 73. 10 square is 100. 73 divides 100. 73 ones are 73. Remainder is 27. 27 square is 729. 729 divided by 73. 73 tens are 730. Negative remainder is minus 1. I hope you got an idea. Why I started with the 7, 11, 13? You should be able to deduce your own divisibility rule. A smart student who has understood my previous examples immediately will say, the divisibility rule for 73 is take a group of 4 digits, alternatively add and subtract. Are you all with me? I am sure you are all there with me. Kindly reply it in the live chat in case if you are there with me. Absolutely scintillating content. If you are listening to a person who has authored 9 mathematical books, why thousands of students sit in my class before half an hour? By this time you should have understood it. Continuously I will take YouTube live classes because I have seen a lot of shit content happening and people doing all that noise. Till the lion enters, every animal will roar. I hope it is clear, right? 10 power 4 divided by 73 is minus 1. 10 power 4 divided by 73 is minus 1. Similarly, I can also do it for 10 power 4 divided by 137 is also minus 1. Now, start from right hand side. Start from right hand side. Take a group of take a group of 4 digits. Take a group of 4 digits. Alternatively add and subtract. Alternatively add and subtract. That is the divisibility rule for 73 and 137. Start from right hand side. Take a group of 4 digits. Alternatively add and subtract. For example, 1, 2, 3, 4, 1, 2, 3, 4 divided by 137. Start from right hand side. Take a group of 4 digits. Alternatively add and subtract. 1, 2, 3, 4 minus 1, 2, 3, 4, it is 0. I hope the idea is clear. Or in other words, any 4 digit numbers, any 4 digit number written, any 4 digit number written even number of times, any 4 digit number written even number of times is always divisible by 73, 137. Are you all with me? 73, 137. 10 power 4 divided by 73 is 1. 10 power 4 divided by 137 is minus 1. Idea clear? Now you can start developing your own questions. I am here to give you the initial push. I am here to tell you the why. What are the concepts we discussed? 7, 11, 13 we discussed. 37, 27 we discussed. 99, 101 we discussed. 41, 271 we discussed. 73, 137 we discussed. Now we will also discuss the divisibility rule for 19 and 17. Please write down one more concepts. These concepts you are not going to get anywhere. Only the enrolled students are going to get this content uploaded in their portal. To all the students who are going to write 2020 exams, right from today, I will upload such a content that probably you will be unbeatable in my domain, that is aptitude. Divisibility rule. Divisibility rule for 19, 17. Divisibility rule for 19, 17. Reminder, a power p minus 1 when divided by p is 1. When a and p are co-prime and p is a prime number. I told you that almost every concept has been heavily inspired from Fermat's theorem. Reminder 1, if it is 19, this will be 10 power 18. This is 1. Similarly, 10 power 16 when divided by 17 is 1. 16 digits, taking a group of 16 digits and adding it will become a very cumbersome process. I will go one step down. 10 power 8 divided by 17. I will take one example. 17 ones are 17. Minus 7. Minus 7 power 8 is 7 power 8. 7 power 8 divided by 17. This is 7 cube whole square into 7 square divided by 17. 7 cube is 343. 17 20s are 340. 3 square is 9. 49 divided by 17. 17 2s are 34. 15. 9 into 15 divided by 17. 17 8s are 136 minus 1. 10 power 8 divided by 17 is minus 1. It is very obvious that if 10 power 16 divided by 17 is 1, 10 power 8 divided by 17 should give you minus 1 or plus 1, because if x square is 1, x will become plus or minus 1. Are you all with me? I got 10 power 8 divided by 17 as minus 1. Now see here. 10 power 8 divided by 17 is minus 1. 10 power 9 divided by 19 is also minus 1. I don't need to tell it. Start from right hand side. Start from right hand side. Take a group of 8 digits. Take a group of 8 digits. Alternatively add and subtract. Alternatively add and subtract. Alternatively add and subtract. We have taken enough examples to illustrate that. What is another concept? Any 8-digit number written even number of times. Any 8-digit number written even number of times is always divisible by 17. 17. Are you all with me? Right? Start from right hand side. Take a group of 8 digits. Why these 8 digits came? Because the power is 8. Suppose if the power is 9, these 8 digits will become 9 digits. These 8 digits will become 9 digits. These 17 will become 19. Simple. Once you understand, once the foundation is strong, you can build as many floors as possible. As Diego Maradona says, when Argentina lost the finals match against Germany, the way you are playing football is incorrect. Everybody is playing with only one motto, to give the pass to Messi. And he says Argentina is not Messi. Messi is not Argentina. Each and every person has got his role to play. You cannot play someone else's role. My role as a teacher is to give you that content that you will have a tsunami of confidence. Mark my words. 5 days listen to my classes. You will understand why thousands of students sit in my class. Why 3,600 students gave us a rating of 4.8 out of 5. It is just because I took a small gap. Right now in one of the Telugu movie, there is a beautiful dialogue which says in Telugu, I'm not sure how many will understand. Gap తీసుకోలేదు, gap వచ్చింది. Right? From today onwards, I will be taking a lot of classes. Unfortunate this content is available only for enrolled students. 10 to 15% content I will release it to the public. I hope this concept is clear. Last concept. Sir, we did it for selected numbers. Can you develop it for any generic prime number? Please write down. Any non-zero single digit written, any non-zero single digit written p minus 1 times, p minus 1 times is always divisible by p. P not equivalent to 235. Any non-zero singular digit written p minus 1 times is always divisible by p. P not equivalent to 2, 3 and 5. This to all the enrolled students, I am keeping a separate video in your online portal explaining you the proof behind why this is happening. Once you know this concept, reminder 1, 2, 2, 2, 2, 2 written 36 times divided by 37. Any singular digit written p minus 1 times is always divisible by p when p is prime. Are you all with me? 55555 written 66 times when divided by 67. Remainder is again 0. Any non-zero singular digit written p minus 1 times is always divisible by p. P not equivalent to 2, 3 and 5. This is a Fermat's theorem proof. I hope the idea is clear. Entire concept, I am sure it should be clear to you. I am sure it should be clear to you. I hope all the ideas are very, very clear to you. Divisibility rule for 7, 11, 13. It is also possible for 77, 91, 143 and 1001. Divisibility rule for 3727, this is also for 999. Divisibility rule for 99 and 101, this also holds good for 99 into 101. Divisibility rule for 41 and 271, which also holds good for 41 into 271. Divisibility rule for 73 and 137, which also holds good for 73 into 137. And what is the last concept? Any non-zero singular digit. Any non-zero singular digit written p minus 1 times, is always divisible by p if p is a prime number not equivalent to 2, 3 and 5. I hope every concept has been very clearly defined. In my next session, I will be doing a lot of problems. I am back to ANC, YouTube live classes. Now it is a Pongal week. Now it is a celebration time. Now it is also the time for us to pull up our socks and start preparing in the right way to achieve the dreams. To all the students who have watched my videos, the first 10 callers, no questions asked, flat 50% discount will be given to the first 10 callers, and also to the first 10 callers, all my books, PDFs will also be shared with zero cost addition. And 120 hours of ANC 2020 YouTube live classes. All live classes are taken by Anil Nair, which itself is worth 6,000 rupees. This both combination is also given absolutely freely. Absolutely freely. Flat 50% discount. I am sorry, I will not be able to give it for more than first 10 calls. First 10 calls, kindly WhatsApp to this number 8050067891. 11th caller, you can purchase it from the website. If bank prep package is 8,850 rupees, you can pay only 4,425 rupees and get this 50% discount. If the most sold course of our SCAT course, 24,000 course, which will have maximum number of videos, you will get at only the 50% discount. I am getting 2 or 3 messages. Thanks a lot. I think first 10 callers, if you love this content, tomorrow also I will come 7 o'clock YouTube live class. Extra 120 hours of latest scintillating, updated, developed content classes taken by Anil Nair will also get added to your portal under the folder ANC YouTube live class videos absolutely freely. This 120 hours only, it is 6,000 plus GST, which I want to give it freely on account of you Pongal celebration and me back to YouTube live classes. Let the 15 years experience speak. Interested, serious and sincere students, please WhatsApp me. Kindly avoid doing calls. Right? Please do not do time waste with me. Interested, I will tell the course details. Interested, first purchase. And this offer is valid only for 30 minutes after the class is over. Before 30 minutes you need to purchase. After that, in case even if you want to purchase, I cannot give the discount. Thanks a lot for your patient listening. I hope you enjoyed the scintillating content. You type divisibility rule for 73 in YouTube, you will not find this approach. You type divisibility rule for 137, please check it out. Sit and spend 30 minutes time in Google, right? And then you will understand the power of Anil Nair. Thanks a lot.